Transformer types. 1. Power transformer. Power transformer used to refer to those transformers that used between generator and distribution circuits. Type 2. Winding transformer. Ratio is more than 2. Autotransformer winding. 1 winding and HV/LV ratio is less than 2. 2. Distribution transformer. Any transformer that takes voltage from a primary distribution circuit and step down it to a secondary distribution circuit or consumer service circuit is called as distribution transformer. 3. Instrumentation transformer. 1. Current transformer. 2. Voltage transformer. 3. Capacitive voltage transformer. What are the applications of transformer in electrical power system? A transformer is not only used to step and step down the voltage in the power system, but there are also other applications which are discussed below. 1. Step up and step down voltage without change in frequency. 2. Reducing the short circuit current. 3. Convert 3-for-3 wire system to 3-for-4 wire system. 4. Voltage regulation with OLTC and AVR. 5. Reactive power control with OLTC and AVR. 6. Converting ungrounded system in LV side in star delta transformer to grounded system using earthing zigzag transformer. 7. Isolation transformer. Types of transformer based on application. There are 3 main applications of transformer. 1. As a generator transformer rating in MVA. 2. As a power transformer rating in MVA. 3. As a service or auxiliary transformer rating in kVA. 4. As a distribution transformer for power supply to household, where the full load MVA rating of the generator transformer should be at least equal to maximum MVA rating of the generator. Where the service or auxiliary transformer rating depends on the load list a total connected load on its secondary side. For the power transformer used in substation rating shall be as per the utility practices. Transformer equipment SLD example. Transformer standard ratings as per substation practices. Transformer vector group. If we take delta-delta connect transformer, then single line to ground fault cannot be detected because there is no any return path for ground fault. Due to this reason we do not take delta connected transformer. Why delta star? Reduce the unbalance on HV side. SLG fault on LV side not reflected as SLG fault at HV side, and zero sequence current circulate inside delta connected winding, and third or multiple of third harmonics eliminated at HV side due to delta connected. Why vector group is important? The vector group indicates the winding configurations and the phase angle displacement between the primary and secondary windings. The three-phase transformer consists of 3 nodes of primary winding, 1 for each phase, and 3 nodes of secondary windings wound on the same iron core. The 2 most common configurations of winding connection are the delta and the star. Winding connection designations. Symbol for the high voltage winding comes first. First symbol, for high voltage always capital letters. D equals delta, Y equals star, N equals neutral. First symbol, for high voltage always capital letters. D equals delta, Y equals star, N equals neutral. Third symbol, phase displacement expressed as the clock hour number 1, 6, 11. The vector for the high voltage winding is taken as the reference vector. Displacement of the vectors of the other windings LV from the reference HV vector with anticlockwise rotation as represented using clock hour figure. Example, DIN11, transformer has a delta connected primary winding, DA star connected secondary winding with star neutral point is brought out in a phase shift of 30 deg leading 11. The phasor representing the HV winding is taken as reference and set at 12 o'clock. Phase rotation is always anti-clockwise. Use the hour indicator as the indicating the phase displacement angle because there are 12 hours on a clock and a circle consists out of 360. Each hour represents 30, thus 1 equals 30, 2 equals 60, 3 equals 90, 6 equals 180, 9 equals 270, 12 equals 0 or 360. Example, note rotation will be anticlockwise. Digit 12 equals 0, that the LV phasor is in phase with the HV phasor. Digit 11 equals 30, that LV phasor is the HV phasor. Digit 1 equals 30, that HV leads the LV winding. Digit 5 equals 150, that HV leads the LV winding. Digit 6 equals 180, that HV leads the LV winding. Transformer vector group in generating power plant. When we connect transformer with generator, then we use the transformer with delta winding on generator side and with star winding on transmission side. As in a power plant, the most valuable equipment is the generator, so need maximum number of protections. Following is the reason we are providing delta connection on the generator side. 1. Delta provide a circulating path for triple harmonics, thus reduces the impact of harmonics on generator. Third harmonics voltage are eliminated since the third harmonics current is circulated in the primary delta and blocks to flow in generator. 2. Delta connection traps the flow of zero-sequence currents commonly known as fault current, so generator is protected from zero-sequence fault currents, blocks zero-sequence between delta-connected circuits. Therefore, delta connection is required on generator side to prevent the zero-sequence current entering into generator, as rotating machines have very little withstand capacity for zero-sequence current enter in generator, then generator core may come under saturation state, and we cannot further use generator, need heavy maintenance on generator. Why neutral grounding resistor? The main goal of grounding through a resistance is to achieve the safety of equipment from the line to ground fault current by limiting the amount of current flow by R. NGR are used to protect generators in special applications, in which generators are connected to bus bars directly feeding single-phase load. In generator, the positive, negative and zero-sequence reactance are not equal. When the neutral is solidly grounded, the line to ground fault currents are usually higher than three-phase short circuit current. This large fault current will damage the laminated core, which increases the cost of repair. Hence, NGR need to be introduced between the neutral of generator and the ground to limit this short circuit current in thousands of amps to thousands of amps. Transformer vector group in solar power plant. In solar power plant, when we connect transformer with solar inverter, then we use the transformer with delta winding on inverter side and with star winding on transmission side. This is called as inverter duty transformer. Now for power export-import transformer, i.e. in power transmission purpose transformer, star-star connection preferred. In this transformer, insulation cost is highly reduced and due to cost economical purpose, and this is cheapest winding configuration transformer and provide facility of graded insulation and so saving in transformer insulation cost and eventually saving in overall cost of transformer. What is graded insulation? In a transformer, one end is earthed, the insulation towards the earthed end could be reduced or graded to reduce the cost. This is worthwhile only for high voltage transformer. Standards specify graded insulation for star interconnected for voltage above 66 kV. In all others, uniform insulation is provided. Large substation tie-up transformer. In EHV substation, the YNA 0D11 type transformer used widely. The meaning of YNA 0D11 is star-connected HV winding with neutral brought out, auto transformer with zero displacement. LV winding delta-connected leading HV by 30. With star connection configuration, the transformer insulation cost is highly reduced, so we are getting the advantage of transformer cost reduction with star winding and have delta connected tertiary winding to get the advantage of delta connect winding. Tertiary winding in a power transformer. Tertiary winding is normally provided in star-connected auto transformer and star-connected transformer of rating 100 MVA and above. Purpose of additional inherent delta is as below. This winding is used as stabilizing winding. The tertiary winding to take out by bushing from transformer to supply tertiary auxiliary loads of the substations. This tertiary winding is connected in delta and allows circulation of zero sequence current in it, thus balancing zero sequence component of unbalanced load. This condition becomes very critical during short circuit fault condition. Further, during impulse withstand voltage surges on HV winding, transferred surge voltages appear on tertiary winding terminals and are quite high, and this was made the tertiary winding as weak link in a power transformer and caused very frequent failures. To overcome this problem, the rating of tertiary winding increased for high current as well as voltage levels. Say for 100 MVA 220-130 seconds of a kilovolt transformer, voltage rating of tertiary winding is now 33 kilovolts, earlier it 11 kilovolts, and MVA rating has been increased to 33 MVA, earlier it was 16.66 MVA. This improved rating of tertiary winding of a power transformer has improved its performance and transformer failures have been reduced considerably. Transformer vector group for LV distribution transformers. For LV distribution transformer, normally DIN 11 vector group using at distribution system. Because star point facilitates mixed loading of three-phase and single-phase consumer connectors. Second reason is that in industries maximum loading is of nonlinear type and they generates the harmonics, and these effect we do not want to reflect in primary grid side. Due to this reason we use delta on primary side. Type of nonlinear load, for e.g. furnace heaters, VFDs in this nonlinear load generates the harmonics in system, for that we use DIN 11. So, whatever harmonics of LV voltage coming from industries, it will not be sent in upstream system due to delta winding in HV winding. Third reason is that whatever a single line to ground fault (SLG fault) occurred at LV side of the transformer, the reflected SLG fault current at HV side not having the zero sequence fault contribution value. In HV side its delta connection, then zero sequence component will not be reflected at HV side, it only circulates within the winding and not coming outside of delta connected winding. Thus HV side of transformer is unaffected by SLG fault, only able to see positive and negative sequence component are reflected when SLG fault occurred at LV, and HV system protected are unaffected by SLG fault. Due to this above reason, in the LV side star connected and HV side delta connected winding configuration is preferred.